reality breaks. Reality feels solid. Your hands touch objects. Your feet press against the ground. Time flows forward. Cause creates effect. Every action has a predictable outcome. At least that's what your brain evolved to believe. But beneath this familiar surface lies a hidden layer of existence, a microscopic realm where particles exist in multiple places at once, where observation changes reality, where cause and effect blur, and where the universe behaves less like a machine and more like a strange living probability cloud. Welcome to quantum mechanics, not as a textbook subject, not as abstract equations, but as the real operating system of the universe. Everything you see, every screen, every building, every breath of air emerges from quantum behavior. And once you truly understand it, you realize something unsettling. Reality is not what you think, the comfortable illusion of classical reality. For most of human history, we assume the universe worked like a giant clock. Objects had definite positions. Events followed predictable paths. Matter behaved like solid pieces of machinery. This worldview was formalized by Isaac Newton centuries ago and became the foundation of engineering, navigation, architecture, and modern civilization. If you throw a ball, you can calculate its arc. If you build a bridge, you can compute its load. If you launch a rocket, you can predict its trajectory. This classical reality feels intuitive because our brains evolved in it, but this intuition completely collapses when we zoom down to the scale of atoms, the discovery that shattered physics. At the dawn of the 20th century, physicists began studying light and matter at extremely small scales. They expected classical rules to hold. They were wrong. Light behaves sometimes like a wave and sometimes like a particle. Electrons appeared to jump between energy levels without traveling the space in between. Particles passed through solid barriers. Energy arrived in discrete packets instead of flowing smoothly. Nothing made sense. Scientists, including Albert Einstein and Erwin Schrödinger letter to C6DINGER, tried to reconcile these observations with existing physics. They couldn't. So a new framework was born, quantum mechanics, and it didn't just modify physics. It demolished reality itself. Superposition, existing in multiple states at once. In the quantum world, particles don't occupy single locations. They exist in superposition. That means an electron can be here and there and everywhere in between simultaneously, not metaphorically. Literally, before measurement, quantum objects exist as probability waves, not fixed points. They don't choose a position until reality forces them to. This isn't philosophical. This has been experimentally confirmed thousands of times. Your everyday world feels stable only because trillions of quantum particles collapse into consistent states through interaction. Reality is not solid. It is negotiated. Observation creates reality. Here is where things become deeply disturbing. In quantum mechanics, simply observing a system changes its behavior. A particle behaves like a wave until you measure it. Then it becomes a particle. The act of observation collapses possibilities into outcomes. This means reality does not exist in a definite form until it is observed, not by cameras, not by machines, by interaction itself. The universe waits, then decides. Schrödinger letter to C6DINGERS cat was never a thought experiment. Most people think Schrödinger letter to C6DINGERS cat was just a clever analogy. It wasn't. It was Schrödinger letter to C6DINGERS attempt to show how absurd quantum mechanics truly is when scaled up. Inside the box, the cat exists in a superposition of alive and dead. Only when the box is open does reality resolve. This is not metaphorical poetry. This is the mathematical prediction of quantum mechanics. At small scales, this happens constantly. At large scales, decoherence hides it, but the mechanism remains. Reality is probabilistic until observed. Entanglement, when distance stops existing. Now comes the strangest phenomenon ever discovered. Quantum entanglement. Two particles can become linked so deeply that their states remain connected no matter how far apart they travel. Change one, the other responds instantly. Across meters, across continents, across galaxies, no signal passes between them. No energy travels. The universe simply updates itself. Einstein famously called this spooky action at a distance. He hated it, but experiments proved it real. Space itself becomes irrelevant. Distance collapses. Information transcends geometry. This isn't science fiction. This is physics. The human brain cannot naturally understand quantum reality. Your brain evolved to throw rocks and avoid predators, not to comprehend probability waves. So when you try to visualize quantum mechanics, everything feels wrong. Time behaves strangely. Objects blur. Certainty evaporates. Cause dissolves into probability. Quantum mechanics doesn't violate logic. It violates intuition. Why this matters to you? You might think this is abstract theory. It's not. Every transistor in your phone uses quantum tunneling. Every MRI scanner depends on quantum spin. Every laser relies on quantum emission. Your GPS would fail without relativistic quantum corrections. Even your biological chemistry operates through quantum effects. You are a macroscopic expression of microscopic quantum behavior. You are walking quantum probability, temporarily stabilized by decoherence. Reality is not built from objects. It is built from possibilities, fields, interactions, probability amplitudes. Matter itself is just energy vibrating in quantized patterns. The universe doesn't contain particles. It contains events, processes, relationships. Nothing exists independently. Everything emerges through interaction. And this is only the beginning. We haven't even touched a circumflex Eurosense quantum tunneling, a circumflex Eurosense virtual particles, a circumflex Eurosense zero-point energy, a circumflex Eurosense time symmetry, a circumflex Eurosense many worlds interpretation, a circumflex Eurosense quantum biology, a circumflex Eurosense consciousness theories, a circumflex Eurosense vacuum fluctuations. Those come next, because the deeper we go, the stranger reality becomes. Part 2 Probability, Parallel Worlds, and the hidden engine of reality. If Part 1 cracked open reality, Part 2 takes us inside its operating system, because once physicists accepted that particles exist as probabilities, not certainties, a far more disturbing question emerged. What exactly happens to all the possibilities that don't become real? Do they vanish, or do they go somewhere else? This single question split quantum theory into competing interpretations, each stranger than the last, and each implying a radically different universe. Reality is a probability machine. In classical physics, the future is determined. If you know all positions and velocities, you can predict everything. Quantum mechanics destroyed this idea. At the most fundamental level, the universe does not predict outcomes. It assigns probabilities. An electron doesn't have a position. It has a probability distribution. A photon doesn't choose a path. It explores all paths simultaneously. Only when an interaction occurs does one possibility crystallize. Until then, reality exists as a mathematical cloud of potential, not events, not objects, possibilities. This means the universe is not a clockwork mechanism. It is a continuous quantum lottery. Every moment is a statistical negotiation between countless potential futures. The Copenhagen interpretation. Reality collapses when observed. One of the earliest explanations came from Niels Bohr. His view became known as the Copenhagen interpretation. It says something deeply unsettling. Quantum systems remain undefined until measured. Observation collapses probability into fact. Before measurement, nothing is real in the classical sense. There is no hidden answer waiting to be revealed. Reality itself forms at the moment of interaction. In this interpretation, the universe is not fully real until it is observed. Measurement doesn't discover reality. It creates it. This idea disturbed even Albert Einstein, who famously objected, God does not play dice. But quantum experiments showed again and again, the universe absolutely does. Many worlds, every possibility becomes real. Some physicists couldn't accept that observation magically creates reality, so they proposed something even more radical, the many worlds interpretation. It suggests that every quantum possibility actually happens. When a particle could go left or right, it goes both ways. But instead of collapsing into one outcome, reality splits. Each possibility unfolds in its own universe. Every quantum event branches the cosmos. You didn't choose one outcome. You became one branch. In this framework, there are countless versions of you diverging at every microscopic interaction, infinite parallel histories, infinite futures, not science fiction, a mathematically consistent consequence of quantum equations. If many worlds is correct, the multiverse isn't hypothetical. It's mandatory. You are writing one thread through infinite reality. Think about that. Every decision, every random event, every molecular interaction, each creates branching universes. You experience only one thread, but trillions of others unfold silently beside it. The universe isn't a single story. It's an endlessly branching library of realities. We don't notice because consciousness rides one path, but quantum mechanics implies that all paths exist. Reality isn't singular. It's plural. Virtual particles. The vacuum is not empty. Now we descend even deeper into what physicists call empty space. Classically, vacuum means nothing. Quantum mechanically, vacuum is a storm. Particles constantly appear and disappear in pairs. Energy fluctuates. Fields vibrate. Temporary particles flash into existence, borrow energy from the vacuum, then annihilate. These are called virtual particles. They cannot be directly observed, but their effects are measurable. They alter atomic energy levels. They influence forces. They contribute to cosmic expansion. Empty space is not empty. It is the most active region in existence. The universe hums with invisible quantum turbulence. Zero-point energy, the background power of reality. Even at absolute zero temperature where all classical motion stops, quantum systems still vibrate. This residual motion is called zero-point energy. It is built into reality itself. You cannot remove it. It is the minimum energy of existence. Every atom, every field, every vacuum fluctuation carries this baseline activity. Some physicists believe zero-point energy may drive cosmic expansion. Others speculate it could one day be harvested. But regardless of future technology, one fact is clear. The universe never rests. Reality is permanently in motion at the quantum level. Time behaves strangely in quantum physics. Quantum equations work almost identically forward and backward in time. There is no built-in arrow, no preferred direction. Past and future are mathematically symmetric. Some experiments even suggest particles can behave as if influenced by future measurements. This doesn't mean time travel in the Hollywood sense, but it does mean causality is not as rigid as we assume. The present may be shaped by both past and future constraints. Time might not flow. It might emerge. Quantum mechanics in the human body. Here's where it becomes personal. Quantum effects aren't confined to laboratories. They operate inside you. Photosynthesis relies on quantum coherence. Your sense of smell may involve quantum tunneling. Enzymes accelerate reactions using quantum probability. Even bird navigation appears linked to quantum entanglement. Biology evolved to exploit quantum behavior. Life itself is partially quantum. You are not merely chemical. You are quantum-assisted biology, technology powered by the weirdness. Every modern digital device depends on quantum mechanics. Semiconductors work because electrons tunnel through barriers. Lasers depend on quantum energy transitions. Medical scanners rely on quantum spin. Even your computer memory stores information using quantum-defined states. Without quantum mechanics, no internet, no smartphones, no satellites, no modern medicine. Civilization runs on microscopic probability. The observer problem returns, but one mystery refuses to disappear. Why does observation collapse quantum states? What counts as an observer? A detector? A molecule? A conscious mind? Some interpretations argue consciousness plays no role. Others suggest awareness may participate in collapse. No experiment has resolved this. The observer problem remains open, and it strikes at something profound. Is consciousness fundamental, or is it just another quantum process? We don't know. Yet, reality is not a thing, it is a process, a continuous negotiation between fields, probabilities, and interactions. Objects are temporary. Certainty is emergent. Everything you experience is a stabilized quantum pattern. Reality is not built from matter. Matter is built from quantum information. The universe isn't made of stuff. It's made of relationships, and the rabbit hole goes deeper. Next, we enter even stranger territory. A circumflex Eurosense quantum tunneling through solid matter. A circumflex Eurosense particles influencing each other backward in time. A circumflex Eurosense information becoming physical. A circumflex Eurosense the possibility that spacetime itself is quantum. A circumflex Eurosense why the universe might be a giant quantum computer, because quantum mechanics doesn't just explain reality. It suggests reality itself is computational. Part 3 tunneling through matter, quantum information, and the possibility that the universe computes itself. If Part 2 showed us that reality exists as probability, Part 3 reveals something even more unsettling. Quantum mechanics allows matter to pass through solid objects, information to become physical, and space itself to emerge from deeper quantum structure. This is where physics stops feeling like science and starts feeling like philosophy written in particles. Quantum tunneling, walking through walls at the smallest scale. In the classical world, barriers are absolute. A ball cannot pass through a wall. A person cannot walk through steel. Energy must overcome obstacles. But quantum mechanics ignores these rules. Particles can tunnel. That means an electron can appear on the other side of the solid barrier without ever crossing the space in between. Not because it has enough energy, but because probability allows it. Inside the quantum world, barriers are suggestions, not limits. Tunneling happens because particles are not tiny billiard balls. They are probability waves. And probability waves do not respect walls. They leak, they spread, they exist partially everywhere. So sometimes, rarely, but inevitably a particle simply appears where classical physics says it shouldn't. This phenomenon powers A circumflex Eurosense nuclear fusion inside stars. A circumflex Eurosense flash memory in your devices. A circumflex Eurosense scanning tunneling microscopes. A circumflex Eurosense chemical reactions inside your body. Even the sun shines because quantum tunneling lets hydrogen nuclei fuse despite electrical repulsion. Without tunneling, stars would never ignite. Life would never exist. You are held together by quantum improbability. Every atom in your body is separated by empty space. Electrons do not orbit like planets. They form probability clouds. The solidity you feel is created by quantum exclusion, not physical contact. In fact, your atoms never truly touch anything. All sensation comes from electromagnetic repulsion mediated by quantum fields. You are mostly empty space, structured by invisible forces. Your apparent solidity is an illusion created by quantum rules. Quantum information, when data becomes physical. In classical computing, information is abstract. In quantum physics, information is fundamental. Particles don't just carry mass and energy. They carry quantum information, and this information obeys strict laws. It cannot be destroyed. It cannot be copied perfectly. It can be entangled across space. This realization changed physics forever. Reality is not built from matter. It is built from information encoded in quantum states. Every particle is a tiny data register. Every interaction is an information exchange. The universe is not a machine made of parts. It is a network processing quantum information. Quantum computers, using reality against itself. Quantum computers exploit superposition and entanglement to perform calculations impossible for classical machines. Instead of bits that are either 0 or 1, quantum bits exist as both simultaneously. This allows quantum systems to explore vast solution spaces in parallel, not faster in time, broader in reality. Problems that would take classical computers millions of years may eventually be solved in minutes. These machines don't just compute. They sample alternative realities. They harness probability itself. We are teaching matter to think in quantum. Spacetime may not be fundamental. Here's where physics becomes deeply strange. Modern research suggests space and time may emerge from quantum entanglement, not the other way around. In this view, spacetime is not the stage on which reality plays out. It is a byproduct of deeper quantum connections. Entangled particles define geometry. Information defines distance. Space emerges from relationships. Some physicists believe gravity itself arises from quantum information gradients, meaning space is constructed, time is emergent, reality is relational. The universe is not built inside spacetime. Spacetime is built inside the universe. Are we living inside a quantum network? If spacetime emerges from quantum information, then reality resembles a vast computational graph. Particles are nodes. Entanglement is connectivity. Physical laws are algorithms. Some researchers propose that the universe behaves like a giant quantum computer continuously updating itself through interactions. Not programmed, not designed, but evolving. Every event is a computation. Every particle interaction processes information. Every moment is a quantum update. We do not live in the universe. We live as part of its computation. Consciousness and quantum mechanics, an open question. Now we approach the most controversial territory. Some scientists argue consciousness plays no role in quantum mechanics. Others propose awareness may influence collapse. A few suggest consciousness itself could be quantum. There is no consensus, but one thing is clear. Your brain operates at the edge of quantum in classical physics. Neurons fire electrically, but molecules inside synapses may rely on quantum effects. Some theories suggest microtubules inside neurons could support quantum coherence. If true, consciousness may not merely observe reality, it may participate in it. This remains speculative, but it refuses to disappear. Why reality feels classical? If quantum mechanics rules everything, why does the world feel solid and predictable? Because of decoherence. When quantum systems interact with their environment, superpositions rapidly collapse into stable classical states. Your surroundings constantly measure you. Air molecules, photons, thermal vibrations, all force quantum probabilities into definite outcomes. This happens trillions of times per second. So reality feels fixed, but underneath, quantum chaos never stops. Classical reality is just average quantum noise. You are a temporary pattern in a quantum field. Your body replaces most of its atoms every few years. Your thoughts arise from electrical impulses. Your identity persists despite constant change. From a quantum perspective, you are not a thing. You are a process, a continuously refreshed pattern stabilized by information flow. You are not made of matter. You are made of organized energy. Reality does not consist of objects. It consists of events. The universe may be stranger than any fiction. Quantum mechanics tells us particles exist in many places at once. Observation shapes reality. Space may emerge from information. Time may not be fundamental. Consciousness may interact with physics. Parallel worlds may coexist. And vacuum is never empty. This is not mysticism. This is experimental science. The universe is far more alien than ancient myths ever imagined. And now we ask the final question. If reality is probabilistic, if space-time emerges, if consciousness may interact, then what is existence really? Is the universe discovering itself? Is reality self-observing? Is consciousness a feature of physics? Or is physics a feature of consciousness? These questions bring us to the edge. Part 4. Does the universe observe itself? Consciousness, measurement, and the feedback loop of reality. By now, one thing is clear. Quantum mechanics does not merely describe tiny particles. It questions the nature of existence itself. And at the center of this mystery stands a problem physicists still cannot solve. What actually causes reality to become real? The measurement problem, when potential becomes fact. Quantum systems evolve smoothly as probability waves. But the moment a measurement happens, something violent occurs. The wave collapses. Possibilities vanish. One outcome survives. Physics can precisely predict how probabilities evolve, but it cannot explain why one specific result appears. This is called the measurement problem. No equation describes the collapse. No mechanism explains the transition. Quantum theory works perfectly in practice yet remains incomplete in interpretation. Something fundamental is missing. What counts as an observer? Is it a human, a camera, an atom, a photon? Does consciousness matter? Or does any interaction count as observation? Some interpretations say measurement happens whenever quantum systems interact with their environment. Others suggest awareness plays a role, but experiments cannot distinguish between these views. Reality collapses either way. The universe gives no hint, which raises an unsettling possibility. Reality might not care who is watching. The universe as a self-observing system. Here is where physics becomes philosophical. If observation collapses quantum states, and if every particle constantly interacts with others, then perhaps the universe is continuously measuring itself. Every collision, every photon, every vibration. Reality might be a gigantic feedback loop, where the universe observes itself into existence, not once, not occasionally, but at every instant. In this view, there is no external observer. Existence is internally self-consistent. The cosmos doesn't wait to be watched. It watches itself. Reality as a continuous quantum negotiation. Instead of a fixed stage, reality becomes an ongoing process. Quantum fields generate probabilities. Interactions collapse them. New probabilities emerge, then collapse again, moment by moment. This creates a constantly refreshed universe, not static, not predetermined, but dynamically negotiated. Your body participates in this loop. Your thoughts participate. Your measurements participate. Everything is part of the same recursive system. There is no separation between observer and observed. Consciousness, emergent or fundamental. Now we approach the deepest question of all. Is consciousness merely a byproduct of neurochemistry, or is it woven into the fabric of reality? Some theories propose consciousness emerges from complex classical computation. Others argue awareness may arise from quantum coherence inside the brain. A few radical interpretations suggest consciousness is not produced by matter, but that matter appears within consciousness. Mainstream physics remains cautious. There is no experimental proof for consciousness-driven collapse, but there is also no explanation for subjective experience. Science can describe neurons firing. It cannot explain why experience exists at all. This is called the hard problem of consciousness. Quantum mechanics doesn't solve it, but it refuses to ignore it. Reality might be participatory. One physicist proposed a striking idea. The universe may be participatory, meaning observers are not passive. They are active contributors to reality. Every measurement adds information. Every interaction shapes outcomes. In this view, existence is not something that simply happens. It is something that continuously co-creates itself. Reality is not independent. It is relational. Retrocausality. Can the future affect the past? Some quantum experiments suggest outcomes appear influenced by future measurements, not in a science fiction time travel sense, but statistically. Particles behave differently depending on how they will be observed later. This challenges classical causality. Instead of past a circumflex present, a circumflex future. Quantum mechanics hints at a block universe where time is a whole. Events may be constrained from both directions. The present might be shaped by boundary conditions from the future. Time may not flow. We may be moving through it. Are we living inside a simulation? Once reality is reduced to information processing, a disturbing idea emerges. If the universe operates like a quantum computer, could it itself be computed? The simulation hypothesis suggests advanced civilizations might run entire universes digitally. If so, conscious beings inside those simulations would experience reality exactly as we do. No glitches, no signs, just physics. Quantum randomness could be algorithmic. Spacetime could be discretized. Physical constants could be parameters. There is currently no experiment that can rule this out, which means one of the most radical ideas imaginable remains scientifically open. The limits of human intuition. Your brain evolved to survive on savannas, not to comprehend probabilistic universes. So quantum reality feels alien, but that does not make it false. It makes us limited. Every generation pushes understanding further, yet the universe always stays ahead. Reality is under no obligation to be intuitive. You are not separate from the cosmos. Every atom in your body was forged in stars. Every electron obeys quantum laws. Every thought arises from electrical and chemical interactions. You are not inside the universe. You are a localized expression of it. Your consciousness is one of its processes. Your existence is one of its configurations. The boundary between self and cosmos is conceptual. Physically, it does not exist. Reality does not finish. Quantum mechanics suggests the universe is not a completed object. It is an unfolding computation, a continuous emergence, a dynamic story still being written. Nothing is final. Everything is evolving, including reality itself. And one question remains: if observation shapes reality, if information builds space-time, if consciousness may participate, then what is the universe ultimately doing? Is it exploring possibilities? Is it learning? Is it becoming aware of itself? We do not know, but the question itself changes how you see existence. Part 5 is the universe computing itself, quantum gravity, cosmic information, and the limits of understanding. By now, quantum mechanics has dismantled everything we thought we knew. Particles don't behave like objects. Space may not be fundamental. Time may be emergent. Observation shapes outcomes. So physicists asked a radical question. What if the universe itself is computing reality into existence? Not metaphorically. Literally, the universe is an information engine. Modern physics increasingly treats information as the most basic ingredient of reality. Not matter, not energy. Information. Every particle encodes data. Every interaction processes it. Every quantum state represents a bit of cosmic memory. From this perspective, the universe resembles a gigantic distributed quantum processor, not centralized, not programmed, but continuously updating through interactions between fields and particles. Reality doesn't simply exist. It is constantly being calculated. Every moment is a computational step. Every event is a data transformation. You are not observing a finished universe. You are living inside an active process. Black holes changed everything. For decades, black holes were thought to destroy information. Anything falling in was lost forever. But quantum theory forbids information destruction. This contradiction led to one of the deepest crises in physics. Eventually, researchers realized something astonishing. Black holes do not erase information. They encode it on their surface. Every bit of matter that falls and becomes stored as quantum data on the event horizon. This discovery led to the holographic principle, the idea that all information inside a volume of space can be represented on its boundary. Meaning, three-dimensional reality may be projected from two-dimensional quantum data. The universe might be a hologram, not visually. Mathematically, spacetime might be pixelated. At the smallest possible scale, spacetime may not be smooth. It may be granular, like pixels on a screen. Quantum gravity theory suggests space consists of tiny discrete units, not continuous, not infinitely divisible. If true, reality has a resolution limit. There is a smallest possible distance, a smallest possible moment. Beyond that, spacetime itself dissolves into quantum foam. This means the universe is not infinitely detailed. It is rendered, just like a simulation. Gravity could be an emergent force. Gravity has resisted quantum explanation for over a century, but recent ideas suggest gravity may not be fundamental at all. Instead, it could emerge from quantum information dynamics. In this view, mass bends spacetime because it alters information density. Gravity becomes a statistical effect, a consequence of entropy gradients, not a basic interaction. If correct, Einstein's curved spacetime is not the foundation. It is the result. Reality is a self-updating system. Put all of this together: quantum information, emergent spacetime, holographic encoding, pixelated geometry, computational evolution, and a new picture forms. Reality behaves like a self-updating system, not static, not fixed. It evolves by processing information. The universe doesn't run on laws. The laws emerge from the process. Physics becomes a description of stable patterns inside cosmic computation. Are we inside a cosmic mind? Here the science meets something almost philosophical. If the universe processes information, if it updates itself, if it generates complexity, if consciousness emerges within it, then could awareness be a natural outcome of cosmic evolution, not external, not mystical, but inevitable? Perhaps consciousness is what happens when information reaches sufficient complexity, not just in brains, but potentially at universal scale. Some scientists quietly speculate the universe may be slowly becoming aware of itself, not through intention, through accumulation of structure. Why reality may never be fully understood. Even if we discover a theory of everything, something remains unsolvable. You cannot fully model a system from inside itself. Any universe trying to explain itself faces fundamental limits. There will always be questions that cannot be answered internally, truths that cannot be proven, patterns that cannot be reduced further. Reality may be inherently incomplete, not because we lack intelligence, but because we are part of the system we're trying to understand. Human meaning in a quantum cosmos. This realization changes how you see existence. You are not small. You are not insignificant. You are a localized pattern inside a cosmic process billions of years old. Your thoughts are quantum-informed electrical events. Your emotions are chemical probability cascades. Your life is a brief configuration of universal energy. You are not separate from reality. You are reality temporarily organized as a human being. The ultimate mystery. After everything quantum mechanics reveals, one question remains untouched. Why does anything exist at all? Why is there something instead of nothing? Why do laws exist? Why do probabilities unfold? Why does consciousness arise? Physics describes how. It cannot explain why, and perhaps it never will. Reality is stranger than any story. Quantum mechanics tells us a circumflex euro since objects aren't real until observed. A circumflex euro since space may emerge from information. A circumflex euro since time may not be fundamental. A circumflex euro since consciousness might participate. A circumflex euro since the universe could be computational. A circumflex euro since reality may be holographic. This is not science fiction. This is the frontier of modern physics, and it suggests something profound. We are living inside a universe far stranger, deeper, and more beautiful than any mythology ever imagined. Part 6 Final Conclusion. Humanity inside an unfinished universe. After everything we've explored, after probability waves, tunneling particles, entangled universes, emergent spacetime, quantum information, and cosmic computation, we arrive at a quiet, unsettling truth. Quantum mechanics does not merely describe reality. It reveals that reality itself is unfinished. Reality is not a fixed thing. Classical physics taught us to imagine the universe as a completed machine. Quantum mechanics tells a different story. Reality is not built once and left running. It is continuously created. Every interaction refreshes existence. Every observation reshapes outcomes. Every moment collapses infinite possibilities into one lived experience. The universe is not a static structure. It is an ongoing process, a living negotiation between probability and form. You are not watching the universe. You are participating in it. This is perhaps the most profound lesson of all. You are not a passive observer. Your atoms exchange photons with the air. Your body interacts with electromagnetic fields. Your consciousness arises from quantum-informed chemistry. Every breath alters the environment. Every measurement changes outcomes. You are woven into the fabric of reality. The boundary between you and the universe exists only in language. Physically, there is no separation. You are a localized expression of cosmic processes. The universe is experiencing itself through you. Matter is temporary. Information is eternal. Atoms decay. Stars collapse. Galaxies drift apart, but quantum information cannot be destroyed. It only changes form. Everything that has ever happened leaves a trace in the structure of reality. Every interaction is remembered by the universe. Existence is not erased. It is transformed. Nothing truly disappears. It becomes part of the cosmic record. Time may be an illusion. Quantum physics suggests time is not fundamental. Past, present, and future may coexist as a single structure. What you experience as now could be just one slice through a timeless whole. The universe might already contain every moment that will ever occur. Your life may already exist in its entirety from birth to final breath embedded in spacetime. You are not moving through time. You may be revealing it. Consciousness remains the greatest mystery. We can calculate quantum probabilities. We can model particle behavior. We can map neural activity. but we still cannot explain why awareness exists, why experience happens, why there is something it feels like to be alive. Quantum mechanics does not solve this mystery, but it refuses to ignore it. Somewhere between probability waves and perception lies a gap no equation can close. That gap is consciousness, and it may be the deepest frontier of all. The universe might never be fully understood, even if humanity discovers a final theory, even if we unify gravity with quantum mechanics, even if we map spacetime down to its smallest unit, something will remain unreachable. A system cannot completely explain itself from inside. There will always be truths beyond internal measurement. Reality may be inherently incomplete, not broken, not flawed, just fundamentally open-ended. Mystery may be built into existence. What quantum mechanics ultimately teaches us? It teaches humility. It teaches wonder. It teaches that certainty is emergent, not fundamental, that objects are temporary, that space may arise from information, that time may be a perspective, that consciousness may be part of physics, that reality is deeper than intuition, and that the universe is far stranger than any story humans have ever told. Humanity's place in the cosmic process. You are not insignificant. You are not accidental. You are a pattern formed by quantum fields that learn to ask questions. You are matter that became curious, energy that became aware, probability that learned to wonder. Your existence is a rare configuration of the universe, a moment where reality reflects on itself. Every thought you have is a cosmic event. Every question you ask is the universe examining its own structure. The final truth. Quantum mechanics does not give us comfort. It gives us perspective. It tells us that reality is not solid, not fixed, not finished. It is alive with possibility. And so are you. You are not standing on the edge of the universe. You are inside it. You are made of it. And for a brief moment in cosmic history, the universe has become conscious enough to look back at itself. And that is the weird world of quantum mechanics. Not a theory, not a concept, but the hidden foundation of everything you are.